Hello, my name is John Melvin. Today, I'll describe two effective methods that will ensure more meaningful and effective multimedia instructional material. When you finish this video, you'll be able to define modality effect, define temporal contiguity effect, and describe how to incorporate modality effect and temporal contiguity effect principles into your multimedia design. Cognitive overload occurs when your cognitive capacity is exceeded by the demands required to process information. Even if the information is meaningful, there can be too much of a good thing. For instance, when an animation is accompanied by a ton of text on screen, a learner's visual channel can become overloaded with essential information. In this situation, the essential processing demands in the visual channel are greater than the learner's cognitive capacity. Here's an example of poor multimedia design. A common two-piece pool cue is comprised of several different components. Now that was a nice overview of the component parts of a common two-piece pool cue, but was the multimedia material helpful? The answer is no. The multimedia in this example can actually hinder the learning experience. The learner's visual channel is being overloaded with all the animation's corresponding text. To promote better knowledge transfer, implement the modality effect, reduce the corresponding text, and present the animation with narration instead. This will reduce cognitive demands in the visual channel and create a better learning experience. Here's an example of good multimedia design, implementing the modality effect. The same graphic is presented, but instead of including the description on screen, the descriptions would be presented as narration instead. In this example, the multimedia explanation is more clear when the words are presented as auditory narration rather than visual text. But using an animation with corresponding narration rather than text isn't enough if you don't utilize the temporal contiguity effect. Let me explain. If an instructor presents an animation and then later provides corresponding narration, then cognitive overload can occur. The learner will be forced to hold the visual representation in working memory to be retrieved later during narration. Here's an example of poor multimedia design. The graphic showing the parts of a standard two-piece pool cue is first shown. Then, a bulleted list is shown, while narration is provided to describe the various parts. Now this was the same overview of the component parts of a common two-piece pool cue, but was the multimedia material helpful? No, it wasn't. By presenting the animation showing the component parts of a pool cue, and then switching to a bulleted list during the narration to describe the various parts, the learning experience is hindered. To promote better knowledge transfer, you should present animations and narrations simultaneously rather than successively. Here's an example of good multimedia design implementing the temporal contiguity effect. Here, you would present the visual animation and corresponding auditory narration at the same time. In this example, the multimedia explanation is more effective when the animation and narration are presented simultaneously. Before we conclude this instructional video, I'd like to test your knowledge. Why should you avoid using too much text with an animation? Go ahead and pause the video and think about how you would answer this question. Then return back to the video to see the correct answer. When too much corresponding text is presented with an animation, the learner's visual channel can be overloaded. Better knowledge transfer results when you implement the modality effect and move some of the essential processing from the visual channel to the auditory channel. Why should you present narration and animations simultaneously rather than successively? Once again, pause the video and think about how you would answer this question. Then, return back to the video to see the correct answer. When you present an animation and then later provide corresponding narration, the learner's forced to hold the representation in working memory and then retrieve it during the narration. Better knowledge transfer results when you implement the temporal contiguity effect and present animations and narration at the same time in order to reduce cognitive load. I hope you've learned some valuable lessons today. Use this knowledge to create more meaningful and effective instruction